Okay, welcome everybody for week 4. I'm so happy to be there for 2 weeks in a row. I'm very happy. And today with me there is Erick. Hi, Erick.
Hello. I'm happy to be here as well. It's been a little longer for me than 2 weeks.
Yeah, true. But now you know what? I think everybody made an appearance on screen for the series. You got everybody there. So remember, it's not only me and Erick, but Erick will present the others, I guess.
Yeah, so we got David. He's my US counterpart, another advocate. I'm an advocate, of course, for anyone who's interacted with me in the past. We've got Erick RAMIREZ. He's our Australian wing. And then we've got, of course, Cedric, who already
Hi.
you already know. We got Bettina, Jack, and Alex, who are kind of our European contingent. So that's the team, and they are the ones who build all this content, put it together, and make it awesome.
Yeah. So today we will discuss about API and microservices. Remember, the first 2 weeks were all about Cassandra. We need you to know the basics, architectures, data modeling, and then week 3 we just explained how to use the drivers on top of Cassandra. And now we are moving more into building applications. It's a bit less Cassandra today, but hey, starting next week, it will be back to Cassandra to put Cassandra in Kubernetes.
But this is the important stuff. This is the stuff that's like, hey, you actually start to see the, click a button and something happens. It's the cool stuff. So
yes,
can't wait.
All right, so this is the agenda for today. Reminders as usual. Then we will discuss about Cassandra and microservices, go into API, endpoints, and access patterns, REST versus GraphQL versus gRPC, and also talk a little bit about Kafka here. And we will close by doing some introduction to Quarkus, and we have a huge surprise for you in the end. I hope you will love it. Okay, so housekeeping. So today we are week 4. So we expect you to have a little bit of things already ready. If not, don't worry. You still have time to catch up a little bit before we go to the exercise mode. So first, you would need an Astra instance. Remember, we created that week 1 to have Cassandra running. You need to have a little bit of knowledge of Cassandra data modeling just to understand the data model of the sample we are running, but we have discussed that into many details last week. And know basics of one of those languages, Python, Java, and C#, because we will code with these 3 languages today. As usual, you don't have to install anything, but if you wanted to run the sample on your laptop, of course, all the materials are on GitHub. You simply git pull, or clone or download everything again on your laptop, and we explain you through README step by step what you would have to do.
It's all self-contained.
As far as we can.
Yeah.
All right, so YouTube is the main live, as usual. I'm reading the YouTube chat as fast as I can, because sometimes there are just too many things. And so does Erick, that he will interrupt me just to get some question answer. We are also...
Or just for fun, too.
True. We are also on Twitch, but that's kind of a backup stream if something happened with YouTube. We are not really reading the question on Twitch, so if you want your question answer live, use either YouTube, as I just told you, or Discord. Remember, we have a Discord room with at least now about 4,000 people there asking questions during the workshop, but also during the weeks. And if you do have longer questions to ask, please use the community.datastax.com. There is a space there. This is where you find the homework as well. And this allows us to start a real thread and keep asking and getting some answer, providing more links, maybe some materials to help you troubleshoot your issues. All right. On the right part of the screen, as usual, astra.datastax.com. This is a Cassandra instance. GitHub. all the source code, all the materials, all the exercise. I should make a meme about that. And last but not least, Gitpod, because we don't want you to install anything, so you will use IDE online, which is called Gitpod. And speaking of which, I told you if you didn't do anything week 1, week 2, or week 3 and want to catch up, you need to go to GitHub. I think we provide you the link below the video in the description. As usual, we do that. And you will go to week number 4, and all we will do is in this single README, we try to put now everything in a single file. And as you can see here, there are 2 prerequisites to do just to be able to do the exercise, but I think we will do the exercise in about 40 minutes. So you do have time to catch up. All right, let's move on to Cassandra and microservices. Okay, let's do this. Monolithic. Okay, it all started with monolithic, everything in a single runtime, and of course, with everything at the single place, it's pretty hard to scale, because if you need more power for the service, yes, you scale the whole application, and it costs a lot. Then if you need to change one piece, the UI got a glitch, you want to change, a typo or something, you need to redeploy the full app. So it was not really what we expect. And of course, pretty soon, I think it was in the 90s, we changed that to multi-tier. Okay, we split front-end, back-end, and the data layer. Pretty obvious. We get out of mainframes and stuff like that. Some used to talk about open architectures, just to have not everything in a single place. And here you can see immediately that, yeah, you can just released the front-end, back-end, and everybody is happy. But now you introduce the network between front-end, back-end, and the data. But still, okay, that was the 90s.
Added complexity with better scaling.
Oh, right? Yeah, you got smaller and smaller, but each time you introduce some complexity. So here I will put that in the beginning of the 21st century, 2000-ish. We talk about SOA, so service-oriented architectures. So instead of having a backend with all things together, we split services by business domain, okay, with a proper goal. And on top of the services, we introduced some middlewares that was called first EAI for Enterprise Application Integration, and then changed to ESB, Enterprise Service Bus. It was kind of, on top of the service, a communication layer, and also do the orchestration for you. In the front end, okay, it started to split by technology. And when people told we are multi-channel, I think, oh, so now you do have mobile app and a website. So, sometimes just multi-channel is not, it's just a bingo or buzzword, or, digital transformation is all about having multiple channels. Yeah, all about the buzzword. Okay, so technically speaking, now you do have different runtime for multiple UI. You have the website and mobile app, dedicated UI for backends, stuff like that. At the data layer, now with more and more data and more usage, RDBMS, it's not enough. Not all the data fit on the single machine, and you need to think about distributed. So let's say 210-ish now, 210-ish. And so NoSQL database have been introduced. Cassandra part of there. Remember, Cassandra has been created 208. And so depending on the use case, now you would have a dedicated backend for your services. And that was also the beginning of Hadoop. Oh, okay. So now we move from SOA to microservice world. So a couple of things. At the front-end level, the big architect, technical architect, in charge of everything, will use his sword and start to slash again in the component to split into small pieces. Now you do have a single page application with multiple modules in there. In your website now you also have some web component inserting here and there. So this is what we call the micro front end. And because you do have multiple parts in the UI, you have dedicated use case and dedicated requirement to have some kind of API to interact with. And now even in the front end, we see some kind of thin backend layer. It's called BFF, or backend for front end, and it's really specialized API for the screen. And those are different, or can be different, for the enterprise services, which fit more a business domain or something related to the business. Backend for front end is also API, but dedicated for the screens.
Can't tell you how many times I've used something like Express Server and Node to build out one of those.
Yeah, totally JavaScript worlds, to be honest. Yeah. Okay, at the service layer, now we talk about microservice. Services are simply smaller, again dedicated to business function, but with their own runtime. In the SOA world, sometimes the services were hosted either on an application server dedicated for that, or directly in the middleware called ESB. But it was pretty huge stack, and you could do some hot deployment, but it was not as easy to have its own runtime that you can scale as much as you want. So let's, next slide is really what is a microservice, but here in a microservice architecture, what's changed is now the service is run its own runtime, dedicated to a function, and some technical capabilities has been externalized. So now you often have something called API gateway on top of the microservice, which is a proxy. It is really simply a proxy, and everything related to authentication, throttling, monitoring can be handled at the proxy level. And so at your service level, you really only need to focus on the business value you want to provide. Also, those services have their own runtime, and they can scale dynamically and at will. And so each time you will spawn an instance of a service, you want to tell your client that, oh, there is a new service to serve what you need, your data. So of course you might think about, oh, it's kind of a DNS naming service, but those naming services are not really dynamic. And so new tools come called service discovery. You probably have heard about Eureka, Consul, or before Zookeeper was one of them at the very beginning. And so etcd as well, famous. So when a new service starts up, it will register itself in the service discovery. And then when you, as a client, want to invoke the service, you will first look up the service discovery to know what are the endpoints available to resolve these the service you need. So
they're really just a small database that keeps track of who's where and what they do.
Yeah, some kind of state machine or something, just holding the state. Yeah, true. And sometimes you invoke the discovery, and the discovery can do a redirect for you. So sometimes it can also be some kind of DNS, but it should not be really used for that. I think that the client should be clever enough to be able to do the load balancing at some point. And also source service mesh that would be introduced more in the container world, which is also some kind of proxy where you can delegate part of your traffic. We will see that a lot, I think, next week or the week after, when we'll discuss about Istio and Envoy. Yeah, we told you, it's not only about Cassandra. During the 8 weeks, we try to share all the knowledge we have to make you successful with building API and microservice. Okay, moving on. Okay, what is a microservice? You know what? I don't want to reinvent the wheel, so I simply took some capabilities from Building Microservice book from Sam Newman. Just give you that it should be highly observable, isolate failure dependent, deploy independently, decentralize all the things. This is also what I put all things distributed at the title of the previous slide. It's also the name of the blog of AWS CTO, Mr. Varnell. Okay, so microservices are organized around business capabilities. I told you that. They are product, no project. Okay. The endpoint is smart. Okay. It was not the case just before. With ESB, the endpoint would be for all the composition, routing, logic. It's not the case anymore. You do have a DOM. You do have your DOM. And this is a client to interact and just invoke you when it needs. Okay, decentralized governance, data management, infrastructure automation. Of course, what you want to do is to do dynamic scaling. So you don't want people just to start instance when you need. Well, you want to have something that monitor your system, and when you're lacking some space or CPU, just spawn new instance for you. It's designed for failure, right? It's based for community hardware. You can lose any service, not a big deal. And even by things that you might say, okay, so you can lose any of the service. Remember, you can lose any of the node in Cassandra. And you will see that microservice is really a sweet spot for the Cassandra database.
It's interesting, just given what we're covering in the next couple of weeks, but what you got there looks like a feature list for something like Kubernetes, almost exactly to a T. So,
yeah, yeah. So I pick a question about what's different from SOA to microservice. To my point of view is, okay, not only having the way to deploy those services change. It used to be hosted in application server, now it's standalone, and the scope. Now it's the scope, the way you shape microservice is really what we call bounded context, so dedicated to a business function, where SOA you would like to be more enterprise-wide and tends to serve multiple purpose. I think microservice is more focused. But the idea is that, again, take your sword and slash into
chop it up into pieces.
Yeah, just to scale only what you need. Okay, so speaking of the microservice, the advantages, of course, main, and this is a success, cost reduction. Okay, you scale only when you need to. The design is simple because now you will focus on your business logic and technical capabilities, authentication, monitoring, throttling, is handled by the proxy on top of you, the gateway, the service mesh. And so as it's simple, you deliver quicker, time to market. So you deliver with speed, confident, and it's simple. And it's costless. So great, right? And because it's simple, it reduces also the risk. Simple deployment, okay? Security and monitoring are done by tools dedicated for that. API gateway with some big names on the market, authentication, authorization, SSO, OO2 standard, stuff like that. It's done by a third party. You simply have to integrate those. It's much easier than reinvent the wheel and implementing your own CAS system. Maybe some old among you have done that in the past. It was not that easy. And also resiliency, of course. You would have multiple instances of your service. You will do load balancing, and as such, you are resilient. But that's not so easy. There are some drawbacks out there. Okay, with a lot of microservice, you will get a lot of complexity. Okay, now, how do you handle fine-grained security, authorization? Depending on which business content, you have to handle that. What about transaction? I will come back to that later, but let's say you want to save an order. So you save the order and want maybe to update the inventory. But that's two different microservices. It's probably HTTP REST, which no transaction. How do you do transaction? How do you do that such kind of distributed transaction? You cannot do anymore. And what about orchestration? now there is less and less ESB that tends to do the orchestration for you, calling the first service, then the second service only when you get the answer of the first. And if the first failed, you try to roll back the first one. People doing some ESB flows, as we used to call that, remember those things. So,
you know, there's an interesting question here. Not exactly on topic here, but I think we should probably touch it before we move on. It's, will moving Cassandra cluster to Kubernetes save cloud costs? That's a maybe. That depends on your infrastructure, how you want to set it up, and what you're actually trying to do. So, kind of a common theme I see is people go, "Oh, we're basically doing all of these little servers to save on infrastructure costs," and when you chop it up into all these small pieces, you know, you don't need to oversize one part just so you can size up another part. And there's truth to that. There's absolutely advantages to having many small containers and being able to size individual parts to what you need. That said, there's overhead with Kubernetes. There's some additional components that need to go in there as well. So it really just depends on what you're trying to do, whether or not you're actually gaining anything from it from a cost in the cloud standpoint.
Yeah. So I got a little bit of challenge on YouTube about cost reduction and Cassandra. Well, I'm discussing about microservice, so let's say the compute unit, not the storage or database yet. It's not a data mesh, so we will go to that very quickly. Okay, last pieces of the microservice world: CI/CD, continuous integration, continuous delivery. You need to make your culture change. Now with microservice, you need to be able to deliver fast, fail fast, or deliver fast, and you need to have the proper CI/CD pipeline ready to go. But
those are actually good things, though. Like having a CI/CD pipeline in place and the whole fail fast mentality are actually big positives. They're kind of improvements to the way you do things. But yeah, culture change is very, very difficult.
Yeah,
for sure.
Indeed, yeah. You know, CI/CD are a bit more old. Are older, I guess. I would move, you know, Jenkins is there forever in my head, so, you know, it's always 10 years ago easily. But yeah, that's part of the microservice world. Okay. Absolutely. So let's move to, this is your microservice as defined in the microservices pattern book. Again, I don't reinvent the wheel. And now I would like to see, how Cassandra fit this microservice world. Okay. So first, looking at number one, in the microservice world, you want to do some distributed tracing, health check, application metrics, application logging. All of those are kind of time series-ish type of data, and that's totally fit what Cassandra is good for. But there are other solutions out there. Of course, you can think about Prometheus and Grafana, or any time series database. But that's the kind of use case you can think about to have Cassandra there in the stack. But not only that. When it comes to testing, in the Cassandra development stack, you do everything you need to do. Unit test, integration test, performance test. And you know what? In week number 7, it will be a full episode dedicated to testing, and you can see whatever exists in all steps of the process to test all your Cassandra microservice, including intensive distributed tests using a tool called NoSQL Bench. And now, and of course, I don't read all the comments on YouTube, but if I would think some senior developer here would think immediately about database per service. Yeah, everybody told that microservice should be, autonomous and run its own database. So of course, if I told you that to run Cassandra you need 3 nodes, you don't want 3 nodes per microservice, do you? Okay, so let's see what I have to say about that. Okay, what you need in a microservice, first you need your service to be loosely coupled. Okay, each service is in charge of its data and is isolated. Okay. We talk about the runtime. standalone runtime, and so you want to do the same. What about the data? Well, first, a shared database, it's different from shared data. Okay, within a single Cassandra cluster, there is multiple ways to isolate your data. You can isolate per key space, and how key space is deployed among multiple rings. Remember, replication factor. You can isolate per table. So you would have a set of tables dedicated per service. Remember, bounded context. And the way to design tables in Cassandra is not the way in relational, where you do have relation in all the duration one-to-many. We are working with denormalized tables, answering dedicated query. So for one microservice, we can totally say you will use those tables and you are only the one to use that. Another level of isolation is role-based access control. Okay, even finer, multiple people using the microservice could have multiple roles and access part of the data or not. And that's the point, coupling infrastructure. And this is what everybody will told. Yeah, but if you lose the database, okay, if you attend the 3 first weeks, you know that with Cassandra, you can lose any of the nodes, okay? And you can make some rings dedicated for some workloads, OLAP, OLTP, and you can have key space deployed wherever you need. So you can totally do some multi-tenancy in a Cassandra cluster to fit multiple microservices workloads. And this is some flexibility of Cassandra that you don't have with database. So my answer to that is, okay, one database per service does not mean one installation of the database per service. That means one data source that needs to be isolated from another. And with Cassandra availability and resiliency, we can ensure that.
Absolutely. You know, there's a couple follow-up questions to the previous slide with CI/CD, just asking how it's a disadvantage. CI/CD in and of itself is not a disadvantage. It's actually a really, really good thing. But what it does when you're moving from kind of a more, I guess, let's say traditional mindset where CI/CD wasn't really a part of what you were doing, it's really hard to shift. I mean, basically, you end up taking, you know, everything you're doing and tying it into kind of an automated test deployment, everything system. And that's a lot of work. That's actually, it's not easy to do. Once you get it, it's great because it will speed up time to deployment. It speeds it up tremendously, but getting there is a bit of a chore, especially if you're coming from a more traditional place. So that's the only way it's a disadvantage. It's a good thing overall, for sure.
And just to answer any questions, SPOF means a single point of failure, meaning, remember, you can lose any part of the infrastructures. Cassandra will still deliver the service as long as you deploy and do the proper data modeling and use some replication factor that is relevant for your use case. Yep. All right, moving on. Okay, I told you about distributed architectures, and now this is my time to challenge you. How do you do ACID transaction in a distributed microservice world?
You don't!
Yeah, you know, they challenge me, I challenge you. That's the game. Yeah, that's pretty hard, right? You can say, oh, back in the day, we have SOAP, and in the SOAP stack, there is something called WS transaction. Nobody used that. Yeah, so it's not that easy. And also, when it tends to have one service where you need to write stuff into database and then stuff into message middleware, and now you also, or multiple data source, now you need two-phase commit distributed transaction. Remember, prepare commit, are you okay? Everybody's fine, we can go, okay, commit. And everybody's go back, roll back. But hey, with API, you cannot do that easily.
Right.
And so to cope with that, something has been introduced. I'm not the one who invented it, and it's called BASE, Basic Availability Soft State Eventual Consistency. And look at that, eventually consistency, again, is totally what Cassandra is doing. It says that availability has higher priority than consistency. And now you want to do event sourcing. So let's say you are handling a ledger, so a banking account. For those, of course, you don't want to get twice the transaction. You don't want to have multiple things. So for those, we saw last week that you can use lightweight transaction, but even then, you can think about event sourcing. Every movement of the account is a line. Okay, you would add, deduplicate those, but add, deduplicate because Cassandra is deduplicated as long as you are using the same primary key. Okay, and when you need to read the amount of money on your account, you will retrieve all the mutation, all the movements, and you will compute the balance at the application side. This is called the ledger kind of data model, and we are using that a lot. You expect the application to build stuff and not have the value pre-baked in your database.
Right.
And I put idempotent there just to say, of course, if you execute multiple times the same event, it's not a big deal because the event has an ID and Cassandra will upsert what you need.
Right.
Okay, so now pattern to the rescue. Again, we did not invent those patterns. We just simply say, oh, now if you want to do distributed transaction on a microservice world that do not provide the layer for that, you can use the saga pattern. So you will need either a choreograph that the ESB used to be to do some transaction one after the other, or you can leverage an event transaction. When the first service is done, you push an event to the second, and so forth and so on, and for those, you introduce some tools like Kafka. And I saw somebody quoting Kafka on the chat. Totally makes sense for that. And by the way, remember, as Advocate, we provide you a full working application in 4 languages, which is called Killer Video, available on killervideo.github.io, running on killervideo.com. To have multiple, to have a transaction like that with multiple small services to invoke, we are using Kafka and we propagate the mutation using events. All right. Second pattern is CQRS, Command Query Responsibility Segregation. That's the big words, simply telling you you will split read and writes and have a dedicated service for each. Remember the ledger, you can have one dedicated service just to basically insert the new values and deduplicate, okay? And you do have a dedicated service to read and building the views you need, meaning you do the aggregation on read. And here you come back with the event sourcing way of thinking. That's quite new from relational database. You tend not to think that way.
Absolutely.
All right, so this is our bold statement. So Cassandra fits very well the microservice because first it's oriented to real-time request and very spot on the scalability. Okay, you want just microservice to scale. Cassandra is known for scaling. It's both based for distributed architectures from ACID to base. So base meaning here basic availability, software eventually consistency. And for the joke, base in French mean alkaline. So that's totally, I can totally do a joke about the pH, hydrogen potential, from acid, lower than 7 to base more than 7.
Acid to base, just don't mix the two, because then you're going to have some...
strange stuff. But, here is alkaline in English. I cannot totally use the same joke. All right, implement CQRS. I told you that. And collocate service and data by putting the service close to, the ring. So the node owning this data. You can achieve that. And also remember, Cassandra have multiple rings. And so you can spawn your microservice on the same data center as your ring. Data center means location, okay, just to reduce the latencies. Easy to do. And Cassandra is known to have a proper topology that fit this kind of reduced latency. And decoupling by design, this is our answer to one table, one query. One not one table, but one database, one service. It's one data source, one service. And so the data source can be isolated using ring, nodes, key space, tables, airbag, and a lot of dedicated queries in the end.
So real quick, it's important to note that there's that small little line in there, co-locate service and data. That's not, it doesn't sound that big until you start thinking about it, where this is actually what allows for some crazy geo-distributed apps, right? Because now my data is where I need it fast. You get rid of a lot of the time on wire latencies that you have to deal with, say, a more traditional system. And it just, everything is where you need it, closest to the user who's actually consuming it. Which, that right there, if that's not a value proposition for Cassandra, I don't know what is. So.
I saw some queries about CQRS. So really the basic notion is to split writes and read. And for instance, in the Cassandra world, you can have, again, time series. You have a dedicated ring to absorb all the sensors sending the data. So the first ring is, let's say, storage intensive SSD disk, something to just be able to absorb this huge volumetry. And then you have something else dedicated to read. And for read, maybe you want to do aggregation. It's more kind of OLAP workload. So you will switch from the driver we saw last week to something called maybe Apache Spark and do the aggregation on another ring. And maybe for this ring, yeah, you will have big CPUs because now what matters is the computation. And then you have split read and writes. That's quite a simple samples, but that's really the idea.
Real quick question in the chat there. Is Cassandra support transaction system for instance commit rollback? So I think what you're asking there is Cassandra basically ACID? Does it support full transactions? No, the answer is quite simply no, it doesn't. There are something called lightweight transactions, but they aren't exactly what you're thinking of if you're thinking of a full relational transaction. There's some fairly big caveats and differences between these two. So just like we said, from ACID to base, base really adopts a different mindset where transactions honestly don't generally fit in the modern world, especially not in the modern microservice world. And a more base approach is just fits better with what you're actually trying to do. So.
Okay, so back to our sample. So 2 weeks ago, we created the data model. Last week, we just implemented the DAO, data access object, to be able to interact with those tables, both the spacecraft and the journey catalog. And today, I promised, I want you to run the app, but the full app, with the UI, the backend, the microservice, the REST API, everything. Okay, so last week, I told you, we have the table in Astra. We have something to implement the DAO using Node, Python, Java, and C#. There were no C# last week, I remember that. I also saw on Discord that somebody re-implemented the backend for Scala, just fabulous. Thank you for that. So today we are doing the layer on top of it, so exposing those services into, let's see which kind of API we can use, and start the front end.
And the front end is just a simple Node.js UI. I mean, it's nothing fancy or complex, but...
Is Node.js really simple? I'm a Java geek.
I suppose it's all a matter of perspective.
Yeah, you start saying Node, okay, Express, Yeah, no, it's not that difficult, to be honest. All right. Okay, and with that, let's go to our exercise. See? Exactly 40 minutes after my sentence telling you that it will be in 40 minutes. Is that good? So accurate on time. Okay, so to run the exercise, everybody go to GitHub and go to always the same repo, Cassandra Workshop series on DataStax Academy account. We are week 4, so no surprise. Go to week 4 folder, and here you can see that we do have backend for C#, Java, and Python, and the UI in Node. Okay, this is our way to mix multiple languages and make everybody happy. But again, we like pull requests, so if you're interested to add more, do it. Okay, so as a prerequisite, you need your Astra instance, okay, and you also need the data model ready to go. So if I go into Astra, I will show you that I'm ready to go. I should. Okay, so this is my database. I go to the studio. I will, you know what? I will simply create a new notebook, new, create, and just I want to see the schema and see that in my key space, whatever the key space you like, but I do have my spacecraft tables, okay, for the location, pressure, speed, temperatures, and of course the journey catalog. Right? Okay, that's a prerequisite. Now we can go. So we have divided the exercise in languages this time. So you can start the backend Java locally, or you can start the backend Java using Gitpod. Again, you don't have to install anything if you don't want to. So to open GitHub, same as last week, simply right-click, open in a new tab, because by default it's open on the same, and you don't want to overlap.
And if you're following along in another language or a local IDE, everything's compatible. Everything's cross-compatible. So the UI will still work the same. You don't have to go download a different one. It's all microservices.
Yeah,
right?
yeah. So question about Scala. So last week we ran the 4 languages: Java, Python, C#, and Node. And that was it. And during this week, as homework, somebody create the backend for Scala. So we simply need to ask him to do the pull request, and I will integrate that. So as of today, I think you cannot do the exercise with Scala, but still there is everything you need to work with Scala soon in the... Now we need to check.
Definitely get that pull request.
Yeah, now we need to chase after people, the guy who implemented, or the girl who implemented the Scala backend. All right. So let's see. I do have Python. I'm a Java guy, so I will probably do the Java part as usual. So, okay. Now it's started. So Gitpod always start at the root of the repo. And so I still need to go to folder week 4. So cd week 4. Okay, and I say I will do Java, but you can. Oh yeah, important to note, for Java, Python, no problem, you can do that with Gitpod. For the C#, you need to install you need to download on your laptop, because Gitpod is running on Ubuntu, and you can go back to Academy. I can show you. No secret here. Here you can see that test C#, and all the tests I run to make it work with C#. But yeah, no luck. C# is really a different beast to make it work on Ubuntu. Anyway, you do have Python and Cassandra. Okay, so let's go to Java. Getting started with Java. Okay, and you will start with Maven, Spring Boot. So for those, you are currently reading the GitHub README, and I'm just doing the same as you. So it will download internet, as usual with Maven.
Got a quick question here. Can you run all of this on your own computer? Yes, absolutely. If that's what you prefer,
exactly.
Just do your pull down, download the zip, or
yes,
or clone the repo, and use your IDE of choice. It'll work just fine.
And I will run the same on my laptop just to show you. But see, for instance, in Java, start the Java backend. There is one way to do it in Gitpod, okay? And right below, we told you exactly how to do it locally, how to run that on your machine. So of course you need Java and an IDE ready. And here you can see that you also have all the requests you need.
Yeah.
I don't remember we had so many dependencies to download. Anyway, okay, so a new port has been opened, 8080. Yeah, let's make it public, and let's open that in a browser. All right. Seems like I do have an API, and it's a REST API.
Hey.
So
there we go, Swagger to the rescue.
Yes. So this documentation is available for the Java. It's not part of the Python, but with Python, you still be able to have the REST API answering your request. We will come back to that, but let's say for now, exercise 1 is really to start the backend, just to see what's going on. So this is my backend. If now you are currently working, if I using the same on my laptop, so see, I have git clone the repo, and I have imported the getting started with Java project. I can show you where it is. So here it is, getting started with Astra Java. I do have a POM, so I can file import project, import Maven project, and it will compile exactly like that. And so because I'm using Eclipse, I love Eclipse. I can run as a Spring Boot application.
I'm not a Java guy, but does IntelliJ have the same functionality there?
Oh, no. IntelliJ is something. Java is beauty of a language. Yeah, of course, on JetBrains and IntelliJ, there is everything you need. There's just a massive, and if you are effective with JetBrains, you're just super effective developer. But same, I know all the shortcuts of Eclipse. I'm very fluent with Eclipse. So I should be able to see the same on localhost now. Yeah, as you can see, I do have my API. And so if you do have your API started, please say it to me, say something on the chat, and we can moving on. Eclipse for old people. Okay, I'm old.
Started a war.
And you know what best part? So I am an open source developer. I've created a framework, a Java framework called FF4J, feature flipping for Java. Okay, shameless plus. But because I'm doing open source Java, JetBrains just told me, oh, you can have the ultimate license for free forever. And I say, no, I'm still Eclipse. So if you want to contribute to open source, I do have ultimate license for contributor. Use Spring Tool Suite. Yeah, this is what I'm using. Spring Tool STS, of course. STS is live. This is exactly what I'm using. Spring Tool Suite. It's written in the top. All right. Eclipse bit. Oh, no, we are just started an IDE war. Okay. We're not in a hurry. I can wait you. So, do you run into any trouble?
Looks like it's going pretty well for most people. There are a couple people running into issues, but it seems like going into Gitpod and running it from there seems to be clearing them up.
Ah, Visual Studio.
Visual Studio.
I
mean,
no, but
I guess.
To debug the C# backend, today I've just downloaded Visual Studio for Mac. So 3 GB just to have a simple UI. Yeah, it's Studio and not code, Visual Code. Yeah, Studio. It's a big thing. But in the end, it worked. But yeah, use the IDE you are most familiar with, and that should be totally fine.
Absolutely.
I don't want to start.
I remember my first job. I was using Notepad++ for writing C++ code.
Yeah, I learned how to code with Notepad++. Yeah.
Oh yeah, those are the days too.
Oh yeah, nostalgic now, nostalgic moment. All right.
Yeah.
Okay. Yeah, so, as usual, homework for the week would be to complete the exercise. So even if you're running into trouble, no big deal. We are here to help during all the week and make you make things work for you.
Absolutely.
Everything seems a bit magical on my laptop, but hey, it's, you know, prepared in advance. But for GitHub,
It's almost like you know what's actually going on.
do I? Let's run a poll for that. Now I do have enemies with me telling me that microservice is not one microservice or one database. Okay, moving on. Let's talk about what kind of API we want to offer to run our backend. We have multiple choices: REST, GraphQL, gRPC, and a lot more. So let's see which one fits in which use case. So first, you might tell that my background is from integration middleware. I told you about ESB, and maybe I was a bit long about that. Yeah, that's totally my previous experience. And we use this schema, and it's still totally relevant. Depending on the volume and the throughput, you won't use the same interface for your service. If you are working with huge volume and low throughput, huge volume, huge throughput, yeah, you probably have to implement your own solution, and this is what does Facebook, Twitter, or any web giant where they have such use case. There is no tool out there to cope with that, so you re-implement that. But when it comes to huge volume, most of the time you are low throughput. So if you want to load a lot amount of value into Cassandra, first things you might think of is SQLSH with the copy from, put a CSV, copy from. But SQLSH is a Python command line interface, and it does not be defined for every huge load. And so up to, I think it's written 2 million record in the SQLSH documentation, it's totally fine, but above, no. So dsBulk, free tool developed by DataStax. So DataStax Bulk is there to help you. It's my next slide, so we'll see, but load CSV into Cassandra. And if you want to load a huge amount of data as well, and you do have the same token ranges, if you want to migrate from one ring to another, and you know that you do have the same token range, yeah, and you can copy the SS table and use a tool called SS table loader. So then, lower volume, but a lot of throughput, but still not real time. Everybody think about Kafka or messaging system, what we used to call GMS, because I'm old, remember? Anything MQ, everybody? MQ, woo! IBM MQ0, MQ, yeah, it was MQ time. Okay, and of course, real time, inserting and request reply in real time, and this is all about API and web service. And for our use case, this is the one we want to use. So back to the kind of workload. So when you do have a huge volume, low throughput, you want to use OLAP. It's called OLAP, okay, for analytic, the A, and for real-time operation, you call online transaction processing. Okay, it's all about real time. And so if you want to read, but you are OLAP, you can use some dedicated tools like Apache Spark as well. All right, now I'm moving on. So dsBulk is the big tool to load. It's free, not open source, but free tool you can download from the DataStax website that could load or unload data coming from Cassandra.
Looks like we have some people running into virtual environment problems in Python. So I would suggest using Gitpod if you're running into issues there, since none of that really applies to the Gitpod environment.
So where you did see that? I don't see.
It's up about a page now in the YouTube chat.
For which language? Python, Java?
Python. Yep.
Yeah, no, Python is already a bit tricky because you probably need to set up some what they call virtual env, because in Python there is 2.x, 3.x, and if you download dependency with pip install, sometimes it's just downloading for Python 2.x, and you would have used rather pip 3 install just to have the proper download.
All of our code is Python 3
yes,
code.
Everything is Python 3. correct.
Yeah.
And even if you downloading in the proper pip repository, and now this is Python install locally data not pointing to the proper repository. And Bettina has written, I think, a pretty nice documentation about that on community.datascience.com.
Right.
And also we do our best to just explain step by step how to set up this virtual env.
And again, if you're on Gitpod, you don't actually need to set it up yourself. It's only if you're doing it locally. It's all done for you on Gitpod.
Oh, I can see something about Debezium. So Debezium is some kind of CDC tool, and it's really fit what I would like to say about message injection. So CDC is really capture something happening on an external system and provide the mutation on another system. So you can do some stuff, change some line in Cassandra and trigger some message and send that to Kafka, for instance. But hey, on the other side, to ingest message coming from outside the world, you probably have heard about Kafka. Kafka is just everywhere. I just want here to mention that we provide Kafka connector sync, which is a way to tell Kafka everything that will go into this topic should be mapped to this Cassandra table. This is not you to do the mapping and to insert data into Cassandra. Kafka do it for you. Okay, so you can do that with Kafka sync. Okay, and you can also use Spark streaming for that. So this time data are in a queue, can be Kafka or anything else, and you do have a Spark streaming job that will read that, do some transformation if needed, and put that into Cassandra. And part of the homework during this week will be to see some videos about the Kafka connector and do a short course about Kafka connector to have your own sample. If you go to the GitHub repo for this week, you can go to sample codes, and I do have a full working demo in Docker. If you want to go there, just Docker compose, start the engine, and you do have something reading from Kafka, writing into Cassandra. As a sample project, it's free for you. And back to the CDC. CDC is really doing the other way around, reading from a storage system and propagate the data on the other direction. This is what they call a Kafka sources. And it's not that easy for Cassandra. You might say, now you all understand the replication factor. So now I want to insert a new data. Okay, I send the data into the 3 replica. When do I know that I should send an event? Because the data has been written in the replica expected. First, you may need the consistency level. So you may need to be there at the coordinator level to be able to propagate this notification. Is not that easy. And so there is something existing with Debezium, but it's not that here. But at DataStax Enterprise, of course, we do have something to do that. And let's see, sooner or later, you will have that as well, free. Okay, so now go, this is file, messaging. What about real-time request? Okay. Again, in request reply, there are multiple strategies. You can do synchronous queries, and this is only what we did last week. No, Debezium is not by DataStax, is Red Hat, I think. So synchronous queries is all about...
They're from 20 years ago. You're showing your age there.
What?
Synchronous queries? Come on.
Yeah.
It's all about async these days.
If you are doing not sync, again, yeah, you feel a bit too young for me. Man, I will mute you now. All right, so everything that we did until now, except for JavaScript, because it's all async, okay, we have defined some statement, put some parameter to create prepare statement, and when we need to execute query, we bind the statement, we execute, and we get a result set. We iterate on the result set to get either rows or result if we are using an object mapper. What the issue here? You might tell, of course, the issue is the big first vertical bar. During all this time, you are blocked. Your client is waiting for the response. So in the drivers, and any drivers, not only the async one, okay, there is a way to invoke async. So async execute against Cassandra. So this time you bound the statement, and instead of having the result, you do have something completion stage, completion feature in the Java world, telling you when the data will be there and ready, you will get a callback where you will be able to process the data, async result set. And by the way, you get a callback per page. Okay? All right, you can do that with any query. Now, what about reactive? So it's all starting the same. Oh, the issue with asynchronous queries, by the way, is if you need to chain or nest multiple asynchronous queries, then you end up with what we call, you know, the recursive, you know, the nested hell, where you need to,
yes.
for the first call, is it okay or not? And depending on the result of the first, you need to interrupt the second, you know, everything like that. And so reactive come to the rescue. And now you can reuse the same kind of API asynchronous, but using reactive. You do have the you do have the method to just properly handle the exception. Let's be like that. So instead of having an async result set, you get a reactive result set, and you get a flux. Okay. The flux, you need to subscribe to the flux to be able to get any notification from something in the flux. And now it's instead of having a notification per page, the reactive drivers, when you execute query, will give you a notification for each record. And if you cannot keep up, then there is a back pressure mechanism. And when everything's done, you get incomplete. And now you can be, you know, totally reactive, get a notification for each new data coming from your request.
Absolutely. So one thing real quick,
Yes,
it looks like it was brought up. So for languages other than Java here, it'll look like you're getting an error, but it is actually working. Just wait it out. It will complete for the labs. So don't worry if you're running in your Python and you hit something that looks like it's a blocker. Just give it a minute or two, and it should complete on its own. So.
Yeah. So no virtual environment in the GitHub. And if you are doing the Python code, when the backend is started, there is no documentation as I show you, but it's totally working. I mentioned that, but let's make it clear a second time. All right, so because the getting started with Astra application is all about request, reply, we will go with API and not file, exchange, or message. We could, but the backend you just started, you just reach out to using HTTP, so you probably know we will use an API. But hey, even with an API, we do have multiple choice: REST, GraphQL, gRPC. So GraphQL is quite new kid on the block. New, let's say new 2.10, I think, has been introduced by Facebook, and so it's leveraging an HTTP, and it's all about providing discoverability for your endpoint. It's a single endpoint you can invoke just to get the list of all the queries for read and mutation for write to interact with your data source. Queries, mutation, seems familiar, right? Okay, working pretty well with Cassandra, right? So this is all the nice ads you can find on the GraphQL.org website. So better apps, parity across platform, powerful partner API, visibility into data, and positive control. I will share with you my own thought about GraphQL in a minute, but let's say that's very relevant for people that won't get answer fitting exactly what they need, because not only you get the discoverability, but when you invoke the endpoint, you can tell that in the response, this is the only 3 feeds I would need, and then you got a custom payload based on what you need.
Right. Yeah, GraphQL really does solve kind of one of the headache problems of a lot of the other
but also
requests.
But my point is not a silver bullet as well. It has some drawbacks, but it's over popular this year. 2020 is the year of GraphQL.
Yes.
Oh, wow. So second path is gRPC. Okay, so based on HTTP2, the idea is to be as fast as possible. So this time, instead of JSON for GraphQL, I didn't mention, you are using some protocol buffer. This is a serialized binary format on top of HTTP, and nonetheless HTTP2, just to be able to use multiplexing and all the nice upgrade introduced in HTTP/2. And so the idea developed by Google, you might tell with the name, right? It's all about the performance, and it's defined to do some request processing call kind of. So you invoke some kind of method. You don't really query for data, you really invoke something. Really like SOAP. Remember SOAP when we used to do that 10 years ago?
Oh man, that's a throwback.
Yeah, you define even to list something, you had to create a method called list, having some parameter, and where you need to post, even if it was about reading. RPC, it's quite the same. You invoke a remote function. So gRPC is there. Performance. All right. Also, when you working with gRPC, it will generate for you stubs. So synchronous, asynchronous, and reactive. Okay, no surprise. And again, if you want a sample, because we will use REST API in the sample. You might tell you just started the example. If you want a running application for gRPC and a running application for GraphQL, they are part of the source code we have this week on the repo. So go there, and there you do have the same API implemented in REST, gRPC, and GraphQL for Java. Okay. Again, we accept pull requests. If you feel you want to do that in other languages, please do. But the sample is all about Java. Same for before the Kafka sample. Injector and reading from Kafka are in Java as well. Okay, so now we do have REST, we do have GraphQL, and we do have gRPC. So as an important architect, I should have a dedicated word for that, technical architect, serious guy. I want to define a decision tree, just to be able to see I want this, that, and that. So, and to be able to do my decision tree, I need first to define my criteria. So I can use conceptual data model criteria, application workflow. Remember, those are the 2 patterns we need to start doing the data model. But not only that, what about the developer? Are they familiar with code first, schema first approach? Is the framework ready to test? What about the API catalog? What is the support for multiple languages? How do we package, do the documentation? You can read the slide again and again. In this analysis matrix, you can find a lot of criteria. So I did the job for you. Here is, I'm French, so I do that in French, even easier to understand, right? You do have all the criteria needed based on GraphQL, gRPC, and REST, and I put some note, and that's it. Now you can use that and do the proper decision tree. What do you think? Easy, right?
It's super easy, yeah.
Yeah, so of course not. This is not the way you will decide if you use GraphQL, gRPC, and REST. I can see you laughing behind your keyboard. I hope you do. Well, instead of providing a detailed decision tree, because it's all based on a lot of criteria, I want to give you some rule of thumb I'm using, or the team is using, not only me. So first, REST is all good for decoupling. So this is a 3 slide you would love to put in your wall. Okay, so REST first is nice to do the decoupling between client and server. We know that the schema is on read. You invoke the endpoint, you get the full JSON stack, and you pick what you want. You do have the flexibility because it's on HTTP. You can do sync, async now with the servlet 3.0, and do reactive, multiple payload, and all the tools for API. I told you about API gateways, remember? They have all created for REST first. So it's pretty easy to do the API lifecycle, retire an API, and also doing the versioning. In a REST endpoint, you can put some major version number, that's a best practice. And you can have multiple endpoints for multiple version of your service. And also, you can do some monitoring and throttling based on the endpoint. So you can say these function available on REST should have this throttling, but this one, same API but different URL, should have another throttle. You can do that with REST.
The interesting thing about REST too, kind of versus the other options out there right now, is that there is so much documentation, there are so many tools built around it, there is kind of such an ecosystem around it, that it's actually really easy to get started, and it's just easy to use. I mean, by default, it's a very simple way to do things. So highly, highly recommend using it as kind of a starting point. And sometimes, GraphQL is a better fit for sure, especially if you have multiple endpoints or various other, requirements. But REST is always a good option to start with.
Yeah, it's a CRUD superstar, like I like to call it. You do have HTTP resources associated with an entity, and you can easily update, create, read, update, delete this entity based on the URL. And this is the reason why one of the reasons we pick REST for our sample, relevant for OLTP mutation, and also for public and web API, because there is a lot of tooling out there. But still, it's not perfect. The payloads are still verbose. Remember, you get the full JSON, no discoverability. So if the clever, smart developers develop some API providing the Swagger specification, you do have the list of the method available, but by default, it's not there. Okay, sample with Python today, the Swagger has not been implemented in our case.
I have actually seen it where sometimes a developer will put an endpoint in that's just a get of all the valid. It's there are ways to do it, I suppose.
Yeah. I remember that a friend of mine just invented the ultimate generic service. It was called do something and take a map as input and a map as output, and with that you can do everything you like. Okay, second is gRPC. So the focus is all about performance. High performance using HTTP2 and binary serialization. You do have multiple stubs. It's very fit when you have to multiply the same API in multiple languages. We could have used that. For instance, in killer video application, this is the one we are using because the API is available in Python, Java, C#, and Java. But yeah, it's using protocol buffer, so it's strongly coupled, not that flexible, and if you do not have the protobuf serialization format, yeah, you screw, you cannot really invoke the API. So it's used for distributed network of service. This is why it has been invented there at Google. It's all about high throughput streaming services, command like RPC. All right, going to GraphQL. The good point about GraphQL is all about this discoverability. You know what there you can invoke. You can do custom payload. It's still matching the standard JSON HTTP, while the previous one as well. So let's say this one is a bit off. But with GraphQL, this is a single endpoint. There is a slash in the URL, and all the calls go through this way. So it's not that easy to do the versioning, monitoring, security. at the API gateway level. So if you assess some API gateway, you might tell that, oh, I'm using GraphQL. Those vendors are not confident with you because, yeah, it's a single endpoint, and they will rather try to make you using multiple small GraphQL microservice instead of a one with multiple mutation or queries available there. The implementation, as long as Java is still complex, you still need to first to define all the query and mutation and entities, and then create the Java code for that mapping. And it's very nice from clients at the UI level, and those are really fit the backend for front-end pattern, but it's a bit too magic. If you invoke ton of things on the GraphQL doing all the composition and aggregation for you, then GraphQL under the hood will do some n+1 select, doing some association, doing a lot of queries to get what you need. So if you do have a lot of a huge base of clients who need to invoke and do specific calls like GitHub, for instance, totally fine. Not if you need some mobile app to get, with reduced bandwidth and want only what they need, totally worth it. But be careful when you define the queries, especially with Cassandra. Don't let GraphQL do some fancy n+1 select or try to do relationships. In some languages, I think the JavaScript one, you just say GraphQL is very easy, but then it's eating very hard the database.
Yes.
Okay, so here is our sample, designing REST API with application workflow. We want the spacecraft catalog, and we have the sensor readings value. Remember, this is exactly the slide from last week. And so we are using API REST, and we are using some standards. So we prefix /API. You can also /API/major version, v1, for instance. Then we are creating the spacecraft. So if we simply say spacecraft, you get the list of all the spacecraft. So sometimes you can add a S here. Then we add the spacecraft name, just to have all the journeys associated to a spacecraft name. Remember the schema in the table? Spacecraft name is the partition key, and then you get multiple journeys. And if you provide now the journey, you retrieve the unique value, and this is your full primary key. And which is neat with REST API is you building resources that accept only queries that are relevant for your database if you did that properly. For one table, you can have one REST resources providing only the granted function, because you don't want to use allow filtering, of course.
Right.
Okay, so with the journey catalog, there is the get, is more or less for you to just read that. You get the get also to get a unique value, and this is what it looks like. Okay, this is for the spacecraft, and you can have the same logic now for the metrics, speed, pressure, location. See, I do have a resources for location accepting get for read, and post to have new value, and same for pressure, speed, and temperatures. Okay.
It's all really simple. I mean, you're basically just using the URL to define what you're trying to do, and then you have a payload attached. It's about as simple as you can get from an easy to read standpoint.
Yeah, for this one, you definitively not need any dedicated client to invoke your endpoint. Like Postman is so...
Yeah, get out your Postman, people. We're going to build some complex queries.
A simple browser can make the trick. You still need the journey ID, but hey, you do have your Astra instance, and you do have the notebooks, DataStax Studio, notebook, SQLSH, whatever you need to get the journey ID. Or you can first get the spacecraft, get the journey of a spacecraft name, and finally get the details of one journey. Okay, and this is the logical architectures of our sample, our demo. So the data is in Astra, communicated with the drivers, Python, Java, and C# backend you started. and we will invoke the REST API using the Node UI. And so now we can jump to second part of the exercise, which is start the UI, make the connection between the UI and the backend, and do the demo. So let's see how it goes. Okay, so to get the Swagger screen, to get the Swagger screen, you need to use a Java backend or a C# backend. It's not implemented in Python. And so to get one, do I need to start it again? Okay, let's see. Some kind of timeout, no big deal. It will show up and I will show it to you. Because now localhost is still there because this is the one I'm running. Okay, Gitpod is starting. Is it the same URL as before or not? So, okay, let's do it again. Week 4, getting started, Java, Maven, Spring Boot, run. We get a little timeout here. Could you please upgrade version node to 12 at least for Astra UI? Yeah, we accept pull request. Okay, so it's now started and I can open a browser. See, I simply have to open browser just to get my Swagger UI because in the Java backend, the default context for the app will redirect you to Swagger UI, and then you find instrument controller and spacecraft controller. So one thing about now, the credential controller. Okay, we could have asked you to insert the secure cloud bundle in the project before starting the backend. Why not? This is exactly what we did last week. But we wanted to change that a little bit. So now we do have dedicated API to accept the cloud secure bundle. So what will happen is we will, at the UI level, you will import the zip file and it will be sent to the backend. So let's see how it goes. So this is my, okay, so this one is Gitpod and this one is local. So if I open a new terminal, you are reading the README, okay, to have all the steps one by one. But guess what? I should be able to do it without reading the instruction. I hope so. So now I'm going to the UI, getting started with UI. I will do the npm install, remember, to download all my dependencies needed. So Express, I think it is, for the UI. Then I need to tell the UI how to connect to my backend. And for that, I will copy paste the URL needed. So let's see. Okay. Hey little guy, this is the API you should invoke. Okay. And so to do it, okay, I'm still in Gitpod. It's still downloading internet, of course. So hey, Node is not better than Java for downloading the whole internet, right? And now everybody's so focused. Okay, okay. Okay, so it seems that now it has been installed. So I will create a file called .env, providing the base URL. Where is my background? I think by default it's localhost. So depending on the language you are using, you don't have to do it. But let's see. It's part of the exercise, and simply read the exercise for your languages. And now you should be able to say npm run start, I guess.
Yes.
And so this little guy now open a new port, 3000, I make available, and I open in a browser. Okay. Jesus. Oh, 3000 not responding.
Oh.
Let's see. All right. Yeah, it needs a bit of time. Okay. Now,
Yeah.
remember, we are ready to go the demo. Okay, so database user, so killer video, KV user, KV password, we use at week 1, key space name, killer video, and use your secure connect bundle you already have on your laptop from last week. If you don't have the cloud secure bundle, let me show it quickly. You go to Astra, homepage, you refresh. Oh no, even Astra is timeout? Jesus.
Oh goodness, your network going out?
We are still there, so it should be fine.
Yeah.
I need to refresh everything. I have too many tabs open. And here you go. Download secure connect bundle. I did that already. I do have my own, but I click that and I could download somewhere. Here it is. Okay. So this is so I'm using a different user than you. It's not a big deal. I'm using my own user password. And key space, I use that. And cloud secure bundle, I use my own. Okay. And I can test the connection. And by testing the connection, I will invoke the backend API, and the backend API will do the connect. So things.
And it'll take it a minute here. There it goes.
Yes. So since we are ready to go, I will save. Okay. So database credential has been saved, meaning at the backend level we have created a temporary file just to have the secure cloud bundle. But in the coming weeks, when we will have to deploy that in Kubernetes, we can either reuse this way of doing, or simply put the secure cloud bundle as a Kubernetes resources that will be used by others. But I won't go into too much of the details. So I should be able to read. Oh yeah, I do have a lot of journey already. So that was last week. Okay. So let's see. Start a new journey. Demo week 4. Okay, journey summary. I do it in GitHub because I worth it, and I launch. And now everybody watching the stream will send hundreds of events to Astra. And Astra team is like, DDoS. No, that's just the workshop. Sending info.
They should be used to it by now. We do that to them like every week.
Yeah, but last week I was the only one doing the 1000 point.
Right.
And okay, it's now down, and I should be able to show here is my new guy, demo week 4, and I can replay that. And if I go to my notebook, you know what? Let's do it. Okay, so the journey as here. I should provide, a partition key, but here is my demo week 4 ready to go.
Boom, there it is.
All right. And if I want to do the same locally, I need I make that bigger. So this one was very ready to. Okay, week 4, I need to go to getting started with UI. This is locally. I should have already .env because it's not the first time I run. I don't need to do npm install because I'm not on the screen. because I already do npm install before, I simply have to do npm run start. Okay, so now I'm doing the demo on my laptop. All right, so I should be able to go localhost 3000. Yeah, and again, of course, it's not the same app, so blah, blah, blah. Up, 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 up. Oh, a problem occur. So, to do password. Problem occur with your credential. How is my localhost doing? This one is happy. Look, let me look here. What do I have? Okay. Oh,
we've got a problem or a comment saying, sorry, I missed what npm stood for. Npm is just basically the way Node handles dependencies, and it's basically the Node everything. If you use Node, you use npm. So the front end is built in Node.
So see my issue? I didn't use the proper backend URL. I was using the C# backend. See, not reading what's written in the documentation. I could have started the backend C#, but yeah, I'm more the Java guy. Okay, so now we are back. Let's do this.
Perfect.
To do app and Cloud Secure Bundle. Here we go. Open, test. Now the guy is more happy, and if I go to my here, session has been successfully established and I've created a temporary file. I can save that. Perfect. And now I interact with the same data set. Okay, so now I have the demo running locally and I do have the demo running in Gitpod. Fair enough. Again, terminating the exercise as part of the homework. We do have 15 minutes to go. I will close that, if you don't mind. Does anybody? I got the UI.
We have a question. Is anyone able to upload the bundle key in the UI? So the Astra Secure Connect bundle is specific to you. So what you have in your Astra as the download is actually going to be only for you. And actually, if you log into the Astra UI and navigate to the page but don't download it, there is it essentially refreshes that link every 5 minutes. So you're going to want to keep that safe. You don't want to put that in any sort of GitHub repo or anything like that. That's basically what you need, or what someone would need, I should say, to connect to your database.
See, the zip file cannot upload on Windows Chrome.
Windows Chrome.
That's
interesting.
Yeah, that seems weird. Is it a limitation for Chrome or for? Yeah, that should be our app. Gitpod is crying. Yeah, so you know what? With last week all together eating Gitpod so much, guess what happened? We just get called by GitHub team. Hey guys, what are you doing with Gitpod? We saw hundreds of connections. Yeah, that was us. And now we are some kind of partnerships to have GitHub as smooth as possible during our workshop.
So thank you guys for that. Yeah. That's actually, it wouldn't have happened without you guys actually doing these exercises.
All right. Okay, so let's do it. Let's close on time. I want really to take the time lead on our little surprise. So Quarkus is a framework to create microservices in the Java world provided by Red Hat. And the idea is to get the backend as fast as possible and the footprint as fast as possible, and also boot as fast. It's all about micro and fast. It also reusing the G2E annotation in API. We might not be used, we are not used to use the Spring API, which has not the GSR. Sometimes it's good to go back to the GSR again, for people developing HTTP with, like me 10 years ago, GSR 3.11, anybody? REST? GIXRS, GSR 3.39 for the GIXRS2. So it's all about the standard. And DataStax released what they call an extension in the latest version of Quarkus, Quarkus 1.6, where you can run a sample REST API on Quarkus plugged to Astra. So that's part of the homework. As an exercise, like today, step by step, create, just run through the example we will provide you, and you would have the Quarkus that will start, in, I don't know, 50 milliseconds, you get everything started and working. That's just amazing. And that's also good to have multiple solutions when it comes to create backend. It's not only about Spring Boot now, you do have alternative, Micronaut, Quarkus. It's always good to have multiple choices. Indeed, to choice. Okay, it was a quick introduction to Quarkus, but at least you know that it's a very efficient framework to build some backend in Java. And we do have the Cassandra extension as one of the first extensions for the technology. So pretty proud of that. It's a very good technology, and it has been thinking for containers for day zero. Because again, if you are running Java in containers for a few years now, you know that first we hit the memory issue before JDK 8, and this is the reason why I think most people move to JDK 11. Then the evolution JDK 9 has been backport to JDK 8 to be able to cope with this container environment. But yeah, that's life. And now,
real quick, before we get into the next piece, for those of you running into some upload issues with the Secure Connect bundle, it's entirely possible that you could have some cross-site scripting protection turned on. And since we're kind of technically, we are cross-site scripting in that example, that could prevent you from doing the upload. So just keep that in mind.
Okay, so we have only 10 minutes to go. I will need everybody's attention for this next 5 minutes. I promise it's worth it. Okay, surprise. We propose you for the next 4 weeks to come to run a hackathon altogether. And we have called it the Astrakaton because it's based on Astra. So you now have the knowledge to go and start building application with Cassandra. Seriously. Data modeling, drivers, and how to package as API, even do some UI. You do have sample codes. So we propose you in the next 4 weeks, so ending the last week of the series, so August 26th, to build a real application with Astra. Pick the language you are confident with, and all the source code that everybody's doing will be shared after the contest on GitHub. So everything we are doing for the hackathon will be shared with everyone.
Open source! Woo!
Yeah, that's the open source way. So if 100 people do the hackathon, you will have 100 sample codes, multiple languages, multiple use cases. This is a very nice way and fun way to build a sample code dictionary. It is not mandatory as part of the homework, okay? It's really some additional game or contest, but it's not mandatory to complete the series, okay? I want that to make it very clear. It's not mandatory to complete the series because it will be some work. For the judges, the whole advocate team, us, and also our VP, Patrick McFadden, and also Jeffrey Carpenter, who wrote the book, Cassandra, the Definitive Guide. So everybody that do the hackathon with us will get a free copy of the Cassandra, the Definitive book, online copy. That's pretty neat, the PDF. And real money to win. Now everybody's waiting me to click next, right?
Yeah.
Okay, when we talk real money, it's real money. So the first seat is a gift card, $300. Second seat, 200, and third, $100. Okay, you can team up to build those samples, but the gift card will be to the team. Okay, to register, how to register? We will provide you the link, and guess what? In the repo you are using, there is something called hackathon.md. Maybe somebody already go there, and the idea is simply do your app, and when you have ready, you do have the code. It's really not registering, it's really submitting your result. It's an alias, so it's astrakaton@datastacks.com. Okay, and we will assess the data model, choices, and hypotheses you made. So fill those on some README for us to just understand what you want to do. The source code, quality and best practice, ease of use. We expect to have dozens, maybe hundreds of submissions for this. So please be kind with us and provide some README that make us available to run your code in a few minutes. If you have no idea, and data model collection, I provide you the link. Maybe I should open this in a new tab. This is a website called Database Answers, and here you have hundreds of data model for RDBMS. Okay, so pick one of those and try to make it fit Cassandra. That's just an idea, but you probably have others ideas, something you want to run at your work. Yeah, make fun.
Build the next Google.
Yeah, it needs to be fun. And so you simply post astrakaton@datastacks.com with your code or a link to your code for us to download. And the only thing is you need to be registered to the series. You need that the email sending the submission is part of the workshop series registration list. And to register to the workshop series list, if you are not already registered and just click on the video because it's live on YouTube, yeah, please register, and we would be happy to have you just to create this small application. Fun, isn't it?
Yeah.
Yeah, I see some superb at least. Yeah, so 4 weeks, we are excited. We are available on Discord to answer your question. It does not to be, you only get the result in the end. Ask us your question again. We always love the question and make you succeed with Cassandra.
Absolutely, interact. That's what we're here for.
Exactly. The whole purpose of that is really to interact with you, create some code, and have fun. And as I told you, pick the language you are confident with. But if you pick Haskell, man, let's see, pick the language you're confident with.
There's not even a Haskell driver, is there?
No, hopefully there is no Haskell driver. Oh, those folks can totally do it. Yeah, let's see what will happen. Okay, yeah. So a few minutes left, only to get a couple of messages. So first, we are currently upgrading Academy and also the way we deliver the certification. So today, starting 4 p.m. Pacific, DataStax Academy will be offline for a few hours, but don't worry, it will be back soon. What we are doing is we are introducing the SSO, Astra SSO in Academy, and also we are migrating the platform to a learn management system. So don't be worried, in the next few hours, Academy should be offline. And also, we got a lot of complaints about how people doing certification, the provider, the people watching you doing the exam, and difficulties to schedule the exam. So we want to do better. So we are changing the certification provider. And this is the reason why in the next 2 weeks, we won't issue any voucher, or you cannot schedule any exam, just for us to set up. But boom, first week of August, we open up again. And if you already have a voucher, you could use it and schedule your exam. And for anybody else watching the series, remember, last week, we will issued the voucher for people with us.
Absolutely.
Okay,
right.
I need to make a slide on that. So Cassandra 4.0 beta version has been released this week.
Out! Yes, finally!
Yeah. So if you want, go there, try it, run it. There is even a Docker image available for you to test. So any feedback is welcome. Get some fun. No extra point in the contest to using Cassandra 4.0, but who knows? That should be a good idea. Either
There's
Astra
a few really cool
Cassandra
features in there too that are documented in the definitive guide. So if you do win that book, you'll actually be able to read about some of the cool stuff in addition to using it.
Yes, and you can read the slide 5 times faster scaling operations. And also now it's run on JDK 11. So now you do have all the no post GC, no streaming, zero copy streaming, way faster. It's there. It's finally there. We do have the beta this week.
Yes.
Okay. Now, last slide for today is about the homework. So, not a lot of courses to track this week. So to learn, I give you, so again, the link for all the exercises in the homework are on the community.datastack.com, same as the week before. Go to the space, it should be on top, homework for week 4. So first, introducing talk for Kafka and Cassandra, the slide about Cassandra ingesting event coming from Kafka. Then doing the short course, no more than 2 hours, few questions, few exercise to know how to set up Kafka to have events coming from Kafka into OSS Cassandra right away. And also, we are releasing a series called Accelerate Series, 12 videos. We had a lot of fun, games, music. You should have a look. It's all about Cassandra, and we explain a lot of things there as well. And so optional, we are running a webinar this week, 10 tricks with Astra, by the PM and PMC of member of the Cassandra, Mr. Mackenzie. So you should really go see the webinar as well, tricks with Astra. And to practice, because this one is all about video, to practice, finish the exercise of the week. In the sample code, you see that you do have GraphQL, gRPC, Kafka if you want to try that. And if you want to try Quarkus, here is a link. And again, as usual, there is a validation form to submit. And with that, you should be ready to go and start working on the hackathon. Who knows?
Absolutely. And don't forget, again, like and subscribe on YouTube if you're watching. It really does help us, and it helps us to know if you guys are appreciating the content or not, and also helps you to be notified when we're actually throwing one of these shindigs. So, yeah, thank you all for coming.
Yes, thank you all, and see you next week for week 5 about Cassandra in Kubernetes. And until now, see you next time.